Today we're going to look further at our exponent rules. So your job is to take a note. So the title for today's note is More Exponent Work. Put today's date with your note. And the first thing we're going to look at are these two examples, Part A and Part B, where we're going to write these in expanded form and then simplify. Now, because this is a video lesson, you have the awesome opportunity to be able to put the video on pause so that you can catch up and write things down and then press play again when you're ready to keep going. So I suggest you put this on pause to get this copied down, and then when you got it copied down, you're ready for the explanation. Okay, you should have that copied down now. We're going to write these in expanded form. Now the first bracket says we have 3x squared. So what that means is we have 3 times x times x. Okay, that's our first bracket there, 3 times x times x. In the second bracket we have 2x squared. So that means we have a 2 times an x times an x. Okay, now all of these things are just being multiplied together. It means I have 3 times x times 2 times x times x. So what we can do with that is we can take our number parts, our 3 and our 2, and we can write them side by side to make that 3 times 2. Because we know the order of operations, it really doesn't matter what order we multiply in. 2 times 3 times 4 is the same as 4 times 3 times 2 is the same as 2 times 4 times 3. We can just shift things around. So I'm moving my number parts to the front, and then I'm going to take the letters here. I have x times x times x times x. So then I have times x times x times x times x. I'm just rearranging the order in which I'm multiplying. What we can do then is actually this multiplication of 3 times 2. 3 times 2 is equal to 6. And then I can multiply or use the simplified form, the power form, to write x times x times x times x. That really is 4 factors of x, or x to the exponent of 4. All right, so my answer to this question up above really becomes 6x to the 4. Now our goal will be to eventually leave out these steps in the middle and to be able to jump from our first line to our last line without having to do all the extra work in between. Okay, so look at what patterns you seem to find there and see if we can make that true for the next one. All right, we're going to write 2a squared in its expanded form and 4a to the 5 in its expanded form. So you can put the video on pause and try that, and then try and put your numbers together and your letters together and see if you can find what your final answer should be. Okay, if you tried that, you should have had 2a times a here for the first bracket, and then we would have a 4 times a times a times a times a times a, 5 factors of a with that 4. All right, if I rearrange things, I can put my number parts first. I can take the 2 and multiply it by the 4, so 2 times the 4, and then we would have times. I have 2 factors of a from the first bracket, so a times a came from here and here. And then I have 5 more factors of a from that second bracket. 1, 2, 3, 4, and 5. So that came from 1, 2, 3, 4, 5. 5 of them there. So 2 from the beginning, 1, 2, and then 1, 2, 3, 4, 5 from the second bracket there. Now what we're going to do is simplify that. We're going to take that 2 and multiply the 4 together, and that's going to give us an answer of 8. 2 times 4 is 8. And then all together here I have 7 a's being multiplied. That means I have 7 factors of a, or a to the exponent of 7. All right, now if I look at my patterns, if I look at what I have happening here, this 6 in part A came from just doing the 3 times the 2. So we're multiplying the number parts together to get the 6. So 3 times 2 gave us 6. And then I'm multiplying, let me use a different color here, let's use blue, an x squared times an x squared. Well, yesterday we talked about when the bases are the same and we're multiplying, the rule is keep the base, we keep an x, and then we add these exponents. 2 plus 2 is what gives us the 4 here. So hopefully that makes sense. Let's take a look and see if that's true for our next one. If I have my 2 and I multiply it by the 4, that's what gives us the 8 here. That's awesome. And then if I look at my letter parts, let's see what else I can find for colors. I've got a squared times an a to the 5. The rule is keep the base a, and then we're adding these exponents. 2 plus 5 is where the 7 comes from. So that's our rule when we are multiplying these monomials together. These are called monomials because we have no adding and subtracting. It's just a multiplication of one term with another term. Now, the same thing is going to happen for our rule if we are doing our dividing, only instead of doing multiplying rules, we're going to do division rules. So let's look at part C here. Part C is going to be 4x to the 5. So that's my first term, my first monomial, and I'm going to divide that by 2x cubed. Now again, I could write these in expanded forms and then simplify, which is what the question was asking. So I could write that as 4 times x times x times x times x times x. So I have 5 factors of x along with a multiplication of 4. I'm going to rewrite that divide sign as a fraction sign. This still means to divide. That really is the divide sign. And then we have a 2 times x times x times x. And because we're straight on multiplying, we can divide parts. If I do 4 divided by 2, that gives me an answer of 2. And then if I do an x divided by x, that's a 1. So they kind of cancel each other out. They undo each other. X divided by x is just 1. I could take my next pair of x's, cancel them out. That's just 1. I could do the next set of x's. They're going to cancel each other out or undo each other. And that's just a 1. So what I'm left with then overall is just x times x, or x to the exponent. That's an x to the exponent of 2. All right, so rule-wise, if we're looking for a shortcut, if I do 4 divided by 2, that's where this 2 comes from. And then x to the 5 divided by x to the 3, the bases are the same, so I keep my base of x. And since I'm dividing, I'm going to subtract my exponents. 5 take away 3 is where the 2 came from. Okay, why don't you try this question, part D. If you want to use the shortcut, you can. I'm not going to make you write out the long form, the expanded form, even though the question says that. You can ignore that for now. We've got negative 3x to the 5 divided by, let's see, 2x to the 3. Okay, put it on pause, try it, and then you can play and see if your answer matches. And I made a mistake here. This was supposed to be 30. I copied it down wrong. That was supposed to be a 30 there. So if you were having trouble doing the minus 2 divided by, or sorry, the minus 3 divided by 2, you could have made that a negative 1.5. That would have worked. Or if you have the correction there, negative 30 divided by 2 would be a negative 15. So that came from negative 30 divided by 2 is where the negative 15 comes from. And then if I have x to the 5 divided by x to the 3, the rule is keep the base the same. So it's going to be x. 5 take away 3 should be a 2. So that's our shortcut to that. The answer is negative 15x to the 2. So hopefully that makes sense for you in terms of that. We're going to do a couple more examples here. I'm going to do, this example here, part E. Okay, I'm going to have 2x to the 3, 2x cubed, all to the exponent of 4. Okay, if I write that in its expanded form, it really means I have 2x to the 3 times 2x to the 3 times 2x to the 3 times 2x to the 3. So if I follow the multiplication for like we did with part A and part B, I have a 2 multiplying a 2 multiplying a 2 multiplying up a 2. That really is 2 to the exponent of 4, okay, which I can calculate by multiplying it by hand, 2 times 2 times 2 times 2. Or I could use my exponent button of 2 to the exponent of 4. And then for my variable part, I've got an x cubed times an x cubed times an x cubed times an x cubed. The rule is keep the base the same. It's going to be an x. And then I could add those exponents together. 3 plus 3 is 6, plus 3 more is 9, plus 3 more is a 12. Or my shortcut, 3 times 4, is where that 12 is coming from. Okay, now that 2, I'm just going to back that up, undo those. Oh! Undo, there we go. I was afraid I'd lost everything there for a second. The quicker way to do that, with the 2 to the exponent of 4, think of 2. It has no exponent written, but remember when there's no exponent written, there's actually a 1 there. So 1 times 4 is what gives us that exponent of 4 right there. So 2 to the exponent 4 is a 16, so that should equal 16x to the 12. Okay, and then you can also simplify some things by following order of operations to that, which I will do on, which you can look at examples in your textbook for.